Okay, guys, here we go, day 4, summation. Let's just do a quick review of yesterday. I'm going to give you a sequence, and I'm going to ask you to do two things for me. One, I'm going to ask you to write a recursive definition, like we did yesterday. And then I'm going to ask you to write the explicit formula, like we did on day 1. So this is a great way to compare the two different ways to represent the sequence. All right, so recursive definition. You always have to state the first term. And then I'm going to say the next term is the one before it. And then can everybody see that it's a minus 10 pattern? It's arithmetic. Remember, you can always sit here and do common difference, second, minus first, and then, put it in your calculator and see. 90 minus 10, enter, minus 10, enter. But I'm trying to give you one that you can clearly see. All right, now let's take the same exact sequence and let's write an explicit formula. So, explicit formula on the reference sheet, a sub n equals a sub 1 plus n minus 1 times the common difference of d. A sub n equals the first term plus n minus 1 times the common difference of negative 10. Now, this is sufficient, but I'm just going to make some room here. If it says in simplest form, or if you don't see this as your multiple choice answer, then you have to simplify. So you got to do the distributive property backwards. So negative 10 times n and negative 10 times negative 1. All right, only blue's working. So we would get, oh wait, it's because I have to go like this. Nope, all right, we're just going blue. So minus 10n plus 10. So a sub n equals 100 minus 10n. So that would be an or on that one. Alrighty, so that's a nice way to show how we could represent a sequence two different ways. Let's also put some more review in here from days 1 to 3. All right, first one. If Brian has puts, okay, so if Brian puts $500 in his piggy bank the first week, so that's like my a sub 1, and he decides to save money each week after that, he saves 2% more than the week before, so now we know this is geometric. Well, they told us anyway. But remember, this is decimal 2%. You have your 2%, so as a decimal, it's 0.02. That cannot be the common ratio because that wouldn't make me increase if I multiplied by 0.02. So remember, increase, 1 plus r. So 1 plus 0.0r. So 1.02. 1.02 is going to be my common ratio. All right, write a geometric sequence to represent what he has week 1, 2, and 3. So week 1, we start out with 500. Week 2, so we're just going to do 500 times 1.02. Enter. Times 1.02. Enter. And there we go. Remember, you can always pause, rewind, listen to it again, whatever you want to do. I'm just going to try to keep going so I can not make crazy long videos. All right, another Regents question, review. It says here, at her job, Pat earns $25,000 the first year, so that seems like my a sub 1, and receives a raise of $1,000 each year. The explicit formula for the nth term of the sequence is, which rule represents the equivalent recursive? Okay, so does everybody see? I'm not sure. This pen stinks. Only blue's working. Great. Okay, so does everybody see that this right here is from the reference sheet, right? So we can tell that a sub 1 is 25,000. We can tell that our common difference is 1,000. Now they want recursive. I hope you can tell that these two are not recursive. These two are recursive. Look, they gave me the first term, which is correct for both of them. And now we just have to say it. So let's say this starting right here. The next term is the one before it plus 1,000. That seems to be the one that's right. Why is this one not right? Well, if you made a number line, here's my n, and here's my n plus 1. So with this guy, I'm saying that each term is the next term plus 1,000. That's not recursive. Recursive is always referring backwards. So choice 3 is it. All right, so let's get into today. Not so bad. It's really just the use of a formula. I'm just trying to get this color to work. It seems like only blue is going to work. Oh no, what just happened? Ay, ay, ay. Okay, let's try again. Nope, only blue is going to work. Okay, we're stuck with blue. All right, so summation. So what we're going to do today is we're going to have the use of a symbol, which is called sigma. So this funky little symbol right here is called sigma. And the number right here is the number that you're going to first plug into your rule, which will come after sigma. And then you'll continue to keep plugging in after the number 1. You'll plug in 2, 3, 4, 5, 6, and then you'll stop after you plug in 7 to get your last term of the sequence. Now, sigma tells me that I have to add the numbers in the sequence. So first let's create the sequence, and then we'll add them up. So I take the number 1 and I replace it in. So 1 plus 5 is 6. Now I'm going to use a plus sign between them because that's what sigma tells me to do, to add the numbers in the sequence. The next number that comes after 1 is 2, so I'm going to put 2 in now for k. So 2 plus 5 is 7. Now I'll put the number 3 in for k. 3 plus 5 is 8. Now I'll put in the number 4. Then I'll put in the number 5. I'll put in the number 6. And then I'll put in the number 7. Now I'll stop with plugging in the number 7 because that tells me the last number to plug in. Add all these up in your calculator. That's what the symbol sigma tells me to do. Add the numbers in the sequence, and you get 63. Okay, another one, very similar. I wish I could get a different marker to work, but only blue will. Okay, first number I'm going to plug in is 3. So 3 squared is 9, minus 2 is 7. I'm going to put a plus sign between it again because this symbol sigma tells me to add up the numbers in the sequence. The next number after 3 is 4. 4 squared is 16. 16 minus 2 is 14. Now plug in the number 5. 5 squared, 25 minus 2 is 23. And then I'll plug in 6. 36 minus 2 is 34. Why do I stop at 6? Because that's what it says to do. Add these guys up, and we get 78. Okay, so it's called sigma notation. There'll be a rule after it. The number on the bottom tells you the first number to plug in. Keep plugging in every number after that until you plug in the top number. Okay, what's different about this one? We have a 2 in front. So that just means at the very end, after we did everything we did before, just multiply that sum by 2. So I'll take the number 3 and plug it in. So 2 minus 3 is negative 1. Negative 1 squared is 1. I'll next put in the number 4. 2 minus 4 is negative 2. Negative 2 squared is 4. I'll plug in the number 5. 2 minus 5 is negative 3. Negative 3 squared is 9. Now why am I going to stop there? Because 5 is the last number to plug in. And now I'm just going to put a little 2 in front because that's what this 2 in front means. Multiply times your sum and you get 28. Okay, next. So they give me the sum. They give me the sum written out, and they want to know which one of these rules would create this. So what I like to do is I like to look at what happens if I plug the first one in So now this I is just a variable I, it's not I imaginary. If I plug in the 1 there, I get 3. The first term in the sequence is 3, so that looks good so far. What if I take 5 and plug it in? So go ahead and put 3 to the 5th in your calculator. And you get 243. Well, 243 is not the last term in the sequence, is it? So I know this guy can't work. Let's take a look at this one. Let's put 0 in. So 2 to the 0 is 1, times 3 is 3. But you can also just put this in your calculator if you don't want to do it in your head. And you get 3. So that looks good because the first term in the sequence is 3. How about if you plug in 4? So if I put in 4, 2 raised to the 4th is 16. Times 3 is 48. Look, that looks like it works. So we're not going to eliminate this choice, but I do suggest like now picking a number in between. So maybe after 0, now I'll plug in 1 just to make sure that's correct. So if I put in 1, 3 times 2 to the 1st, we're left with 6, that works too, and so on. So this guy is it. If you tried doing these other two, they wouldn't work. Okay, number 5, a little application. Peter puts $900 in an account each year that pays 5% interest. Again, we should be thinking about exponential. We should be thinking about geometric. We should be thinking that this is 0.05. It's an interest question, compounded annually, so 1 plus R. So 1.05 is going to be my common ratio. He does this for 7 years. Represent the sum in sigma notation. Okay, so we're going to write our own sigma now. When we know we're starting with 1, and we're going up to 7. But now I have to put the rule in front there. So here is going to go my rule, or my explicit formula. So let's try that off to the side. This is geometric. So the explicit formula for geometric from day 2, a sub n equals a sub 1 times r to the n minus 1. So the first term, so if the first term is going to be the $900 times the common ratio of 1.05 raised to the n minus 1. So I'll throw that guy right in front here. And that's it. You wrote it in sigma notation. If you need to, rewind that and do it again. Any of these videos you can pause and watch again. Okay, just 2 more. Another application. So Cassidy is training for a fundraising run. She wants to increase how much she runs by 12% per week. So again, we know this is exponential. We know it's geometric. So turn it into a decimal. We know we need to do 1 plus the rate to get that common ratio. So 1.12 is going to be my common ratio. If she runs 6 miles in week 1, so that's my a sub 1. I'll write that down here. And she wants to train for 8 weeks. Write an expression in sigma notation to find the total number of miles that she should run. Bless you. So we're going to do our own sigma notation. So n equals 1. We're going up to 8 weeks. I'm going to have to write a explicit formula for geometric again, just like we did for the previous question. I'm just going to use the space over here. So a sub n equals a sub 1 times r to the n minus 1. That's where we're going to put our rule. So a sub n equals the first term, which was 6 miles. The common ratio is 1.12 raised to the n minus 1. And I'll throw that rule right in here. Okay, so we wrote our own sigma notation. Okay, one more, because we're not going to do number 8. We don't need to do that one. Oops. Oh, God. Okay, there we go. All right. All right, which of the following represents a sum? So we did one just like this before. I'm giving you the sequence. You have to figure out which one of these works. So I would always try to do first and last terms, see if you can eliminate anything. But then you do need to kind of check the middle sometimes too. All right, so let's try this guy. So we're going to plug in 4. 2 times 4 is 8, minus 2 is 6. So that looks good so far because that is the first term. Now let's plug in 7 to see what our last term is. So 7 times 2 is 14. 14 minus 2 is 16. So that's not what the last term is. The last term is 39, so this guy's no good. All right, let's try this one. Let's put in 4. 4 squared is 16, minus 10 is 6. Okay, that looks good. Let's check out the last one. 7 squared is 49, minus 10 is 39, so that looks good. But just be careful. We should check one in between. Let's check n is 5. If I put in 5, 5 squared is 25, 25 minus 10 is 15, and 15 is my second term, so that does look good. So choice B would be my answer. All right, I think we're looking good. So that's summation. Not so bad. So practice. Go back, watch the video again. And I think homework for this one looks like packet page, let me see. Okay, so I'm not having you, yes, I guess I'm not having you, I'm not assigning this as your homework. I'm assigning this one. Okay, so this big graphing question for you guys to do. And you can look back, I have it all done already, but I want you to do this, and then you guys are doing Delta Math U12 Day 4. All right, guys, good luck. Work hard. Watch the videos over again. Pause them. You can do it. All right, bye.